Tonight, we are going to listen to the universe and discover what makes the silence so disturbing. Far above the noise of cities, beyond aircraft, satellites, and the faint glow of our own atmosphere, an observatory turns toward the night. Its instruments stare into a darkness filled with stars. Every antenna is ready. Every detector is waiting. And then, nothing. No message, no unmistakable signal, no voice from another world, only the quiet hiss of the cosmos. At first, that silence seems peaceful, almost beautiful. But the longer we listen, the stranger it becomes. Because the universe is not small. Our Milky Way alone contains hundreds of billions of stars. Beyond it lie hundreds of billions of other galaxies, each containing their own stellar populations. And around many of those stars are planets. Worlds orbiting suns we will never visit. Worlds separated from us by distances so enormous that even light needs years, centuries, or millions of years to cross them. Among those worlds are planets that may orbit within what astronomers call the habitable zone, the region around a star where temperatures could, under the right atmospheric conditions, allow liquid water to exist on a planet's surface. But there is a distinction that is easy to miss. A habitable zone is not a life zone. A planet at the right distance from its star is not automatically alive. It could have no atmosphere. Its surface could be chemically hostile. Its star could bombard it with radiation. Its climate could be unstable. Or life might simply never begin. The habitable zone tells us only that one ingredient may be possible. It does not tell us that anyone is home. And yet, the discovery of thousands of confirmed exoplanets has changed the question we ask. For most of human history, we knew of only the worlds of our own solar system. Earth appeared unique because it was the only planet we knew existed with oceans, an atmosphere, and life. Then astronomy began finding planets around other stars. Suddenly, Earth was no longer an isolated example. It became one member of a much larger planetary population. The universe began to look less like an empty ocean, containing one island, and more like an ocean filled with islands whose shores we have barely begun to see. That should make the search for life seem inevitable. Instead, it has made the silence more difficult to understand. For decades, scientists have searched for evidence that another technological civilization might exist. The search is known as SETI, the search for extraterrestrial intelligence. But SETI is not simply pointing a radio telescope at the sky and waiting for an alien voice. Scientists look for patterns that nature is unlikely to produce by accident. A narrow-band radio signal, a repeating pulse, a laser flash, an unusual concentration of energy, or another technosignature, an observable effect suggesting that technology may be operating somewhere beyond Earth. The idea is simple. If another civilization has developed technology powerful enough to communicate across interstellar distances, perhaps its presence could leave a detectable signature. So radio telescopes have listened. Optical instruments have searched for laser pulses. Researchers have examined stars, planetary systems, and regions of the sky for unusual signals. The search has continued for decades, and so far, no extraterrestrial signal has been confirmed. That sentence sounds much more dramatic than it really is, because there is an important scientific qualification. We have not searched everywhere. We have not searched every frequency. We have not examined every star with unlimited sensitivity. We have not searched for every possible form of technology. The universe is too large, and our instruments are still limited. Imagine standing on the shore of an ocean at night. You shine a flashlight into a tiny patch of water. You see nothing. Can you conclude that the ocean contains no fish? Of course not. You have sampled only a fraction of an enormous environment. The cosmic search is similar. Our silence is real. But our sample is incomplete. And this is where the mystery becomes much deeper. The question is not simply whether extraterrestrial life exists. Simple life may be common, or it may be extraordinarily rare. The harder question concerns intelligence. How often does life evolve into organisms capable of manipulating technology? How often does intelligence create civilization? How long does a technological civilization survive? And how often does it become capable of communicating across interstellar space? Those questions are connected by a chain of probabilities. Life must begin. It must survive. It must become complex. Intelligence must emerge. Technology must develop. And the civilization must remain technologically capable long enough for another civilization to notice it. At any one of those steps, something could go wrong. Perhaps simple life is common, but complex cells are rare. Perhaps complex life is common, but intelligence is extremely unusual. Perhaps intelligence appears frequently, but technological civilizations rarely survive for long. Or perhaps advanced civilizations become so different from us that we would not recognize their signals at all. This is why the night sky cannot be interpreted as a simple yes or no answer. Silence does not mean absence, but it does mean something important. It means that, after decades of listening, humanity still has no confirmed evidence that another technological civilization is communicating with us. And that creates a problem first articulated in a deceptively simple question. If the universe is so vast, if stars are so numerous, if planets are so common, if the universe has existed for roughly 13.8 billion years, then where is everyone? The question became famous through physicist Enrico Fermi. The story is associated with a conversation in the early 1950s when Fermi reportedly asked a version of the question that has haunted scientists ever since. Where is everybody? It sounds almost casual, but hidden inside it is a profound contradiction. The universe has had an enormous amount of time. Human technological civilization is extremely young. Our radio age is barely a century old. Our species has existed for only a tiny fraction of cosmic history. If another civilization had emerged millions of years before us, its technological development could be almost unimaginably far ahead. It might have explored its planetary system, built enormous energy-harvesting structures, sent autonomous probes between stars, or left technological signatures spread across its galaxy. We should not assume that any of these things must happen. A civilization may have no interest in expansion. Interstellar travel may be much harder than we imagine. Advanced societies may choose to remain quiet. And our assumptions about what intelligent life wants may simply reflect human psychology. But that uncertainty is precisely what makes the problem so fascinating. We are looking into a universe containing more stars than the human mind can comfortably visualize. And we are asking whether intelligence has appeared anywhere else. So far, the universe has given us no confirmed answer, no unmistakable beacon, no artificial message, no verified civilization. Only silence. And perhaps the most unsettling possibility is not that the universe is empty. Perhaps the silence means that something is preventing civilizations from becoming visible. Maybe intelligent life is rare. Maybe technological civilizations disappear. Maybe advanced beings communicate in ways we cannot detect. Or maybe they have learned something that we have not. Maybe the safest civilization is the one that never announces itself. Before we go further, subscribe to the channel, join the conversation, and tell us in the comments where in the world you are listening from tonight. A silence caused by distance would be one thing. A silence chosen deliberately would mean something entirely different to us tonight. Because from this point onward, we are going to follow the silence into one of the most disturbing questions in modern astronomy. If everyone is silent, what if they have a reason? And if that reason is survival, then the darkness above us may not be empty at all. The universe is not merely old, it is almost unimaginably old. Earth formed about 4.5 billion years ago. Our sun is more than 4 billion years old. The Milky Way has existed for roughly 13 billion years, and the universe itself has been expanding for about 13.8 billion years. Human civilization, by comparison, is almost impossibly young. Agriculture appeared only thousands of years ago. Modern science is only a few centuries old. Radio technology has existed for little more than a century. And our ability to deliberately search the heavens for technological civilizations is younger still. That enormous difference in age creates the central tension behind the Fermi Paradox. It is not really asking whether aliens exist. It is asking something more uncomfortable. If intelligent civilizations have had billions of years to appear, why don't we see the consequences? The question is famously associated with Italian-American physicist Enrico Fermi. During a lunchtime conversation in 1950, Fermi and several colleagues were discussing faster-than-light travel, extraterrestrial civilizations, and the possibility of visitors from other worlds. According to the famous account, Fermi suddenly asked a deceptively simple question. Where is everybody? The question was not a formal equation. It was an observation. If the galaxy has existed for billions of years, and if intelligent life can emerge on more than one planet, then even a civilization only slightly older than ours might have had an enormous amount of time to spread. So where are the traces? Where are the probes? Where are the signals? Where are the engineered stars? Where are the unmistakable fingerprints of civilizations that should have arrived long before humanity? This is where the paradox becomes powerful. Our civilization does not need to be the oldest technological civilization in the galaxy. In fact, statistically, there is no obvious reason why it should be. We appeared after billions of years of cosmic history. If intelligent life emerged somewhere else, even 1 million years before humanity, that civilization would have had a 1,000,000-year head start. To us, 1 million years sounds almost incomprehensible. But on a cosmic timescale, it is surprisingly short. 1 million years is enough time for continents to move dramatically, species to appear and disappear, climate systems to transform, and, potentially, technology to advance through countless generations. Now imagine a civilization that developed not 1 million years before us, but 100 million years earlier. The technological difference could become impossible to imagine. Trying to compare such a civilization with modern humanity might be like comparing a stone tool with a supercomputer. Perhaps that comparison is still too conservative. We cannot predict what technology looks like after millions of years. Our own technological history demonstrates how quickly possibilities can multiply. For thousands of years, human societies depended primarily on biological energy and simple machines. Then came steam, electricity, radio, computing, nuclear energy, artificial intelligence, spaceflight, all within a tiny fraction of cosmic history. If technological progress can continue for millions of years, an older civilization might become almost unrecognizable. And that leads to another crucial concept: galactic colonization. It does not require faster-than-light travel. A civilization would not need to cross the galaxy in a single journey. Instead, imagine a chain. A spacecraft travels from one star to another. It establishes a settlement. That settlement eventually builds new spacecraft. Those spacecraft travel to additional stars. Each new colony becomes another launch point. The process repeats. One civilization becomes many, then many become thousands, then millions. The expansion front moves outward through the galaxy. The process could be extremely slow compared with the speed of light, and still cover enormous distances over astronomical timescales. Even if individual journeys required centuries, a civilization with millions of years available could potentially spread across a substantial fraction of the Milky Way. This idea does not prove that galactic colonization is easy. Far from it. Interstellar travel presents enormous engineering challenges. Energy requirements are immense. Radiation is dangerous. Life support systems would need to function for extraordinarily long periods. Autonomous machines would have to repair themselves. Civilizations would need to maintain continuity across generations. And there is another problem we often overlook. Why assume that an advanced civilization would want to colonize the galaxy at all? That is a deeply human assumption. Human history contains exploration, migration, competition, resource extraction, and territorial expansion. We therefore tend to project those motivations onto hypothetical extraterrestrial civilizations. But another species could have completely different priorities. Perhaps advanced civilizations become less interested in physical expansion. Perhaps they retreat into artificial environments requiring very little material. Perhaps they devote themselves to computation. Perhaps they value stability over exploration. Perhaps they recognize that interstellar expansion creates more risks than benefits. Or perhaps the very concept of civilization changes after technological development reaches a certain level. A civilization might no longer consist of biological organisms living on planets. It could become distributed across machines. It could exist inside highly efficient computational environments. It could communicate using methods we have never considered. It could deliberately minimize its energy signature. And if so, we might be staring directly at its environment without realizing what we are seeing. This is one reason the Fermi Paradox does not have a single solution. There are dozens of possible explanations. Maybe technological civilizations are extraordinarily rare. Perhaps intelligent life requires such an unlikely sequence of events that Earth is an extreme exception. Maybe microbial life is common throughout the galaxy, but complex organisms almost never emerge. Maybe intelligence appears occasionally, but technological civilization almost never follows. Or perhaps civilizations develop technology and then destroy themselves. This possibility leads directly toward the Great Filter, one of the most unsettling explanations we will examine later. But self-destruction is only one possibility. A civilization could disappear because its planet becomes uninhabitable. Its star could evolve. Its ecosystem could collapse. A biological catastrophe could eliminate complex life. A technological accident could destroy its infrastructure. Or civilization could simply become quiet. Perhaps advanced societies stop broadcasting powerful signals into space. That possibility matters, because our search depends on what we expect technology to look like. For roughly a century, humanity has been producing radio leakage, television transmissions, radar signals, military communications, satellite communications. Some of these signals travel outward at the speed of light. But the strongest signals are not necessarily traveling equally in every direction. Many communication systems are relatively weak. Others are highly directional. And as technology improves, civilizations may become more energy efficient, reducing the amount of detectable leakage. A sufficiently advanced civilization could therefore be technologically active while appearing almost invisible from another star system. This creates a crucial distinction. Undetected does not mean non-existent. Our telescopes do not see civilizations directly. They see signals, energy, atmospheric changes, unusual structures, or other measurable consequences. If an extraterrestrial civilization does not produce a signature we know how to recognize, we could completely miss it. The Fermi Paradox, therefore, depends partly on our assumptions. We assume advanced civilizations should be visible. But perhaps that assumption is wrong. Maybe the galaxy is full of civilizations that have simply learned how not to be noticed. And that brings us back to the silence. The Great Silence is not evidence that the galaxy contains no intelligent life. It is evidence that we have not yet detected convincing evidence of intelligent life. Those are very different statements. The distinctions may sound like scientific caution. It is much more important than that, because each possible explanation leads to a completely different picture of our future. Perhaps we are alone. If so, Earth may be one of the rare places where intelligence has crossed the enormous chain from chemistry to consciousness to technology. Perhaps life exists everywhere, but intelligence is rare. Perhaps intelligent civilizations are common, but technological civilizations are short-lived. Perhaps advanced civilizations exist but communicate through methods we cannot detect. Or perhaps they know we are here and have chosen not to answer. These possibilities can be organized into three unsettling categories. They are not there. Maybe the universe is simply far less populated by intelligence than our imagination suggests. They are there, but we cannot detect them. Their signals may be too weak, too distant, too brief, too unusual, or fundamentally different from what our instruments are designed to find. And then there is the third possibility. the one that transforms the silence from an astronomical mystery into a question of survival. They are there, and they deliberately remain silent. Perhaps silence is not the absence of a signal. Perhaps silence is the signal. Perhaps civilizations that survive long enough to understand the dangers of revealing themselves eventually stop broadcasting. And perhaps every civilization that fails to learn that lesson does not remain visible for very long. If that possibility sounds extreme, the next chapter will take it seriously. Because there is a hypothesis in which the galaxy is not an empty ocean, but a dark forest. And every light in that forest may be taking a terrible risk by revealing where it is. Chapter 3: The Dark Forest. What if everyone is hiding? Not because the universe is empty, not because intelligent life never appeared, but because every civilization that survived long enough learned the same lesson: never reveal where you are. Imagine a forest at night. There are no streetlights, no roads, no signs, only darkness between the trees. You know other beings could be somewhere nearby. You cannot see them. You cannot hear them. And you have no way of knowing whether they are peaceful, frightened, desperate, or dangerous. You are carrying a weapon. So is everyone else. You could shout into the darkness and announce that you are here. You could light a fire. You could send a signal. But the moment you do, every unseen observer learns something extremely valuable: your location. The dark forest hypothesis takes this simple thought experiment and expands it to the scale of the galaxy. It is not an established scientific law. It is not evidence that extraterrestrial civilizations are hiding. It is a speculative idea, proposed as one possible explanation for the Fermi Paradox. And yet, its logic is disturbing. The basic premise begins with a problem that every technological civilization might eventually face. You cannot know what another civilization wants. Imagine detecting a signal from a planet 20,000 light-years away. The signal appears artificial. You send a response. 20,000 years later, the civilization receives it. Perhaps they answers. Immediately. Another 20,000 years pass before their reply reaches you. A conversation has now taken 40,000 years just to complete one exchange. During that time, neither civilization remains exactly the same. Governments change. Cultures disappear. Technology advances. Species evolve. The original civilization might even cease to exist. There is no possibility of an ordinary conversation. There is no telephone call across the stars. No real-time negotiation. No way to sit across a table and ask, "What are your intentions?" That creates the first major problem. Uncertainty. Suppose you detect an alien civilization that is technologically comparable to humanity. Its first message appears friendly. It says hello. It describes its world. It sends images of its oceans. It tells you that it wants peace. Should you believe it? Perhaps. But what happens 10,000 years later? The civilization may change. Its political structure may collapse. Its artificial intelligence may gain control. Its population may develop completely different goals. Its descendants may no longer share the values of the civilization that originally transmitted the message. A peaceful civilization today does not guarantee a peaceful civilization forever. And from across interstellar distances, there is no reliable way to verify the change. This is the problem of trust on a cosmic scale. Human beings have developed institutions to manage uncertainty. We negotiate treaties. We establish borders. We create international organizations. We communicate constantly. If two countries misunderstand each other, diplomats can meet. If a crisis develops, leaders can speak directly. But between civilizations separated by hundreds or thousands of light years, none of these mechanisms work. There may be no second chance, and that leads to an even darker possibility. What if the safest strategy is not to trust first? What if it is to eliminate the potential threat before the potential threat can eliminate you? This is the logic of preemptive defense. Imagine that you detect another civilization. You do not know whether it is hostile. You do not know whether it is peaceful. You do know one thing. If it becomes technologically superior to you in the future, you may no longer have any way to defend yourself. Waiting could therefore become dangerous. The rational strategy, under an extremely pessimistic set of assumptions, might be to strike first, not because you hate the other civilization, not because you know it is evil, but precisely because you do not know. That is what makes the dark forest idea so unsettling. The danger does not require evil civilizations. It requires uncertainty. Two civilizations could both prefer peace and still become enemies. Both might think, if they attack us first, we are finished. And therefore, we must make sure they cannot attack us. A tragedy could emerge without anyone intending it. The logic becomes self-reinforcing. Fear creates secrecy. Secrecy creates uncertainty. Uncertainty creates suspicion. Suspicion encourages defensive preparation. Defensive preparation looks threatening to the other side, and that threat encourages even greater secrecy. Eventually, every civilization has a reason to remain silent. Silence becomes a survival strategy. This is where the metaphor of the dark forest becomes powerful. Every star is a tree. Every technological civilization is a hunter moving silently between them. Nobody knows how many others are nearby. Nobody knows which ones are stronger. Nobody knows who is watching. And nobody wants to be the first civilization to turn on a flashlight. Because the flashlight does not merely say, "Hello," it says, "I am here." And that distinction becomes critical when we consider how humanity has behaved. For more than a century, Earth has been producing radio emissions. Some are deliberate, many are accidental. Televisioned broadcasts, radar systems, radio communications, powerful astronomical transmissions. Our technological footprint has been expanding outward at the speed of light. That does not mean an alien civilization could simply look at Earth and immediately know everything about us. Interstellar detection is vastly more difficult than popular culture suggests, but given sufficient technology and sufficient distance, some signatures could potentially reveal that an active technological civilization exists here. Humanity has also deliberately sent messages beyond Earth. The Pioneer spacecraft carried plaques containing information about our species and the location of the Sun. The Voyager spacecraft carried the Golden Record containing sounds, images, music, greetings, and information about life on Earth. These messages were created with a remarkably optimistic assumption that another civilization might someday discover them, that it might be curious, that it might be peaceful. that communication across the stars could be an act of friendship. From the perspective of the dark forest hypothesis, however, there is another interpretation. We have been leaving footprints in the darkness, and we do not know who can follow them. But there is an important problem with the dark forest argument. It assumes that civilizations behave according to a particular set of motivations. It assumes resources are sufficiently scarce to create competition. It assumes expansion is valuable. It assumes civilizations are capable of destroying one another across interstellar distances. It assumes technological development tends toward greater power. And perhaps most importantly, it assumes that civilizations cannot establish reliable trust. None of these assumptions has been demonstrated. We have exactly one technological civilization to study: us. That is not a large enough sample to determine how intelligent life behaves across the galaxy. Maybe advanced civilizations do not compete for resources. Perhaps technological progress makes material scarcity less important. Perhaps highly advanced societies become extremely efficient and require almost no physical expansion. Perhaps they retreat into artificial worlds. Perhaps they communicate through methods we cannot detect. Perhaps they deliberately avoid interfering with younger civilizations. Or perhaps they simply have no interest in us. There is another possibility. Maybe the galaxy is not a forest at all. Maybe it is an enormous collection of civilizations that have never encountered one another because the distances are simply too great. A galaxy can contain hundreds of billions of stars while remaining extraordinarily difficult to cross. The speed of light imposes a fundamental limit on communication. A civilization could send a message today and wait centuries for a response. It could send another message and discover that the civilization it was trying to contact had disappeared before receiving the first reply. In such an environment, silence does not necessarily require fear. It may simply be the natural consequence of cosmic distance. This is why the dark forest hypothesis remains controversial. It is compelling as a thought experiment. But it is not an observation. We have no evidence that extraterrestrial civilizations are hiding. We have no evidence that advanced civilizations routinely destroy emerging civilizations. We have no evidence that the galaxy is filled with silent hunters. The hypothesis becomes powerful only when combined with the uncertainty of the Fermi Paradox. And perhaps that is why it continues to capture the imagination. It turns one of the most beautiful sights humans have ever known, the night sky, into something psychologically unfamiliar. Every point of light becomes a possibility. Every silent star becomes an unanswered question. And every unanswered question leaves room for fear. Imagine again that you are standing in that forest. You cannot see the other hunters. You do not know whether they exist. You do not know whether they are watching. You do not know whether they are friendly. You have one decision. You can turn on your light or remain invisible. If you live in a forest and have no idea how powerful the creatures around you are, would you really switch on a light and announce your exact location to everything hiding in the darkness? Humanity may already have done exactly that. But there is an even more disturbing possibility. What if the reason the forest is so quiet has nothing to do with hunters hiding between the trees? What if almost every civilization that reaches a certain level of technological power simply does not survive? Then the silence is no longer a strategy. it becomes a graveyard. And that possibility leads to one of the most frightening ideas ever proposed to explain the Fermi Paradox. What if almost everyone fails before becoming visible? That question changes everything. The Fermi Paradox begins with the apparent contradiction between a vast, ancient universe and the absence of confirmed evidence for extraterrestrial technological civilizations. The dark forest offers one possible explanation. Maybe civilizations are hiding. But there is another possibility that is even more unsettling. Maybe they are not hiding. Maybe they are gone. The Great Filter is a hypothetical explanation for the Fermi Paradox in which one or more steps between a lifeless planet and a long-lived, spacefaring civilization are extraordinarily difficult. So difficult, perhaps, that almost every civilization fails before reaching the point where it becomes visible across interstellar distances. Imagine the history of a planet as a series of locked doors. The first door is the formation of a suitable planetary environment. The next is chemistry capable of producing increasingly complex molecules. Then comes the emergence of life itself. After that, perhaps single-celled organisms must survive long enough for complex cells to appear. Those cells must eventually cooperate. Multicellular organisms must emerge. Nervous systems become more sophisticated. Intelligence develops. A species learns to manipulate its environment. It discovers tools, agriculture, writing, science, industrial technology, then electricity, computing, spaceflight. Eventually, perhaps, a civilization becomes capable of surviving beyond its home planet. And somewhere along this enormous chain, there may be a filter, a step so unlikely, dangerous, or unstable that almost every world stops there. The crucial question is not whether every civilization encounters obstacles. Of course they do. The question is whether one obstacle is so severe that it almost completely prevents civilizations from becoming long-lived, technologically advanced, and visible across the galaxy. If such a filter exists, we have no idea where it is. And that uncertainty creates two radically different possibilities. The first is strangely comforting. The Great Filter could be behind us. Perhaps one of the earliest steps toward intelligent life is extraordinarily improbable. Maybe the transition from chemistry to self-replicating life almost never happens. Perhaps simple life is common, but complex cells are exceptionally rare. Maybe multicellular life requires an incredibly unlikely sequence of environmental conditions. Or perhaps intelligence itself is the improbable step. The universe could contain countless planets with microbial organisms, while almost none produce a species capable of building a radio telescope. If that is true, then humanity may already have passed the hardest barrier. We would not be ordinary. We would be extraordinarily rare. Perhaps the most difficult step in cosmic evolution has already happened here. That would make our existence not evidence that the universe easily produces technological civilizations, but evidence that something incredibly unlikely has already occurred. This possibility changes the meaning of the silence. If civilizations are rare because the difficult steps occur early, then the absence of extraterrestrial signals is not necessarily frightening. It may simply mean that Earth is an extraordinary exception. But there is another possibility. And this is where the great filter becomes genuinely disturbing. The filter could be ahead of us. Perhaps becoming intelligent is not the hardest part. Perhaps becoming technological is not the hardest part. Perhaps the truly difficult challenge begins after a civilization acquires enough power to destroy itself. Consider the timeline of humanity. For most of our existence, our technological capabilities were limited. A human being could kill another human being. A tribe could destroy another tribe. But the damage remained geographically constrained. Then industrial civilization transformed the scale. We learned to extract enormous amounts of energy. We developed chemical weapons. We developed biological technologies. And, eventually, we split the atom. Nuclear weapons introduced something fundamentally new. A technological civilization could acquire the ability to cause destruction on a planetary scale. That does not mean nuclear war is inevitable. It is not. Nor does it prove that nuclear weapons are a great filter. But it illustrates the basic problem. Technology increases capability. Capability increases both opportunity and risk. A civilization may become powerful faster than it becomes wise. And nuclear weapons are only one example. Imagine a future in which biotechnology becomes cheap enough for small groups to engineer dangerous pathogens, or autonomous systems become capable of making decisions faster than humans can intervene. Or artificial intelligence becomes dramatically more capable while alignment and control remain unresolved. Or environmental degradation creates cascading failures across food, water, energy, and political systems. Or increasingly complex technological infrastructure becomes so interconnected that one major failure triggers others. None of these scenarios is guaranteed. None should be presented as a prediction of humanity's future. They are examples of possible filters. The Great Filter does not require a single dramatic apocalypse. It could be gradual. A civilization might experience declining resources, political fragmentation, economic collapse, demographic decline, ecological deterioration, loss of scientific capability. Eventually, it may become unable to maintain the technological infrastructure required for interstellar communication. It would still exist, but it would no longer be visible in the way we expect an advanced civilization to be. This raises an important distinction. The Great Filter does not necessarily have to destroy every individual. It only has to prevent technological civilization from continuing toward long-term interstellar expansion. A civilization could survive biologically while losing its technological trajectory. It could return to a lower energy state. It could abandon large-scale industry. It could deliberately stop broadcasting. It could simply fail to become a civilization that leaves enormous signatures across the galaxy. That possibility makes the silence difficult to interpret. Perhaps the universe is not filled with extinct worlds. Perhaps it is filled with civilizations that never crossed the final threshold. But there is another clue scientists consider. If advanced civilizations can survive for millions of years and develop technologies far beyond ours, then we might expect some of them to produce techno-signatures that are easier to detect than our own. Large-scale energy use, artificial atmospheric chemicals, powerful electromagnetic emissions, unusual heat signatures, massive engineering projects. or other technological effects that alter the environment of an entire planetary system. We have not found confirmed evidence of such civilizations. Again, this does not mean they do not exist. Our searches remain incomplete. Our assumptions may be wrong. But the absence of obvious ancient civilizations is still part of the puzzle. Because time is the disturbing variable. The universe has had billions of years. Human technological civilization has existed for only a tiny fraction of that time. If technological intelligence commonly survives for millions of years, why do we not see civilizations dramatically older than ourselves? That question cuts deeper than simply asking, where are the aliens? The more frightening question is, why don't we see civilizations older than us? Imagine discovering a planet around a distant star. Its atmosphere shows signs of chemistry. Its oceans appear stable. Its continents have existed for billions of years. But there is no radio noise, no artificial lights, no orbital infrastructure, no obvious technology. Nothing. One explanation would be that intelligence never evolved there. Another would be that intelligence emerged but never developed advanced technology. Another would be that technology emerged and disappeared. If we discovered this pattern repeated across thousands of worlds, the implications would be profound. But we have not yet performed such a survey. We do not have thousands of inhabited planets to examine. We do not know how often life emerges. We do not know how often intelligence evolves. We do not know how long technological civilizations survive. This is why the Great Filter remains a hypothesis rather than a discovery. There is currently no confirmed evidence that a universal filter exists. The idea is powerful because it provides a framework for thinking about the silence. But the silence itself does not tell us where the filter is. And that creates an extraordinary asymmetry. If we discover simple life on Mars, Europa, or another nearby world that could tell us something about the first steps toward life. If we find complex life elsewhere, the implications become even larger. And if we discover a civilization that existed millions of years ago and survived, the Great Filter hypothesis would face an entirely different challenge. Every discovery changes the probability landscape. That is why future searches for life matter so much. We are not simply looking for aliens. We are looking for evidence about the sequence of events that produces technological civilization. Every microbial fossil, every biosignature, every atmospheric anomaly, every technosignature could become another piece of the puzzle. Perhaps the Great Filter is behind us. Perhaps life itself is extraordinarily rare. Perhaps intelligence is the cosmic bottleneck. Perhaps technological civilization is almost impossible to sustain. Or perhaps there is no Great Filter at all. Maybe the Fermi Paradox has nothing to do with extinction. Maybe interstellar civilizations simply do not behave the way we expect. They may remain local. They may become difficult to detect. They may communicate through technologies beyond our current understanding. They may have no interest in expansion. The universe may be full of life that leaves almost no trace. We simply do not know, and this uncertainty is essential. The Great Filter should not be used to predict that humanity will inevitably destroy itself. That would be far beyond the evidence. Instead, it offers a question, a warning disguised as a hypothesis. What happens when a species gains enormous technological power before it understands how to survive the consequences? Humanity has already crossed several thresholds that earlier generations could not have imagined. We can alter the climate. We can manipulate genomes. We can split atoms. We can create machines capable of learning. We can place instruments beyond our planet. And yet we remain biologically vulnerable, politically divided, and dependent upon a fragile planetary ecosystem. Perhaps survival is not guaranteed by intelligence. Perhaps intelligence creates new risks as quickly as it creates new possibilities. That is the uncomfortable heart of the great filter. Civilizations may not disappear because they are stupid. They may disappear because technological power grows faster than their ability to control it. And if that is true, then the silence above us acquires a completely different meaning. If the great filter is behind us, humanity may be extraordinarily lucky. We may already have crossed the hardest barrier. The universe may simply be waiting for other worlds to catch up. But if the great filter is ahead of us, the silence may be a warning that the transition from planetary civilization to interstellar civilization is not automatic. A warning that intelligence alone is not enough. A warning that reaching the stars may require surviving ourselves first. And perhaps the most unsettling possibility is this. Maybe the night sky is not silent because civilizations never learned how to speak. Maybe it is silent because almost none survived long enough to finish the sentence. For most of human history, Earth was quiet. Our planet moved through space without announcing itself. No radio towers, no television broadcasts, no radar networks, no artificial lights visible from another star. To a distant observer, Earth would have appeared to be just another small planet orbiting an ordinary star. Then, within the span of a few generations, everything changed. We learned how to transmit information through electromagnetic waves. We learned how to build powerful radar systems. We filled the atmosphere with radio signals. We began broadcasting television. We launched satellites. We developed spacecraft. And suddenly, the Earth was no longer completely silent. We had begun to leave a technological fingerprint in the darkness. This is the part of the story that brings the Fermi Paradox back home. Because if the dark forest hypothesis is correct, and there is no evidence that it is, then the question is no longer simply whether other civilizations are hiding. It becomes something much more uncomfortable. What if they can already see us? To understand that question, we first need to understand what it means for a civilization to be visible. When we think about communication across space, we often imagine an intentional message. A radio transmission directed toward a distant planet. A laser pulse sent deliberately toward another star. A signal that says, "We are here." But technology can reveal a civilization without anyone deliberately trying to communicate. Every civilization produces unintended emissions. Humanity is no exception. Radio and television broadcasts have been escaping Earth for decades. Radar systems send powerful pulses into the sky. Some satellite transmissions radiate energy beyond our immediate surroundings. Navigation systems produce electromagnetic signals. Military radar can be extraordinarily powerful. Astronomical observatories themselves transmit signals. Together, these emissions create what scientists call technosignatures, observable effects that could potentially indicate the presence of technology. But there is an important complication. Not every signal travels equally far. A weak radio transmission spreads outward and rapidly becomes difficult to distinguish from background noise. A highly directional radar beam can be far more detectable along its path. An intentional communication signal could be designed to maximize its visibility. So when we say Earth is becoming visible, we should not imagine a giant glowing beacon surrounding the planet. There is no simple spherical bubble announcing our existence equally in every direction. Instead, there is a complicated and constantly changing electromagnetic footprint. Some signals are weak, some are powerful, some are accidental, some are highly directional, and some are deliberate. That distinction matters, because accidental leakage tells another civilization that technology exists here. An intentional message tells them something more. It tells them that someone wants to be heard. Humanity has deliberately sent messages beyond Earth before. In 1972 and 1973, NASA launched Pioneer 10 and Pioneer 11 toward the outer solar system. Attached to each spacecraft was a small metal plaque. It contained a symbolic message describing humanity, a representation of a man and a woman, a diagram showing the position of the sun, a map using pulsars to indicate where Earth is located. The intention was not to contact an alien civilization directly. The probability that another civilization would ever discover one of these spacecraft is extremely small. The plaques were more like cosmic time capsules, a message placed aboard a machine traveling into interstellar space. A quiet statement that, somewhere on a small planet, intelligent beings had learned how to leave their world. Then came an even more ambitious message. The Voyager Golden Record. Voyager 1 and Voyager 2 carried gold-plated records containing sounds, images, music, spoken greetings, and information representing life on Earth. There were recordings of nature, thunder, birds, whales, human voices, music from different cultures, images of our planet. The record was designed as a kind of introduction. If another civilization someday discovered Voyager, perhaps it could reconstruct something about the species that created it. The spirit behind these projects was overwhelmingly optimistic. Curiosity, scientific exploration, a belief that contact with another civilization might be one of the greatest discoveries imaginable. There was no assumption that whoever found the spacecraft would be hostile. But the dark forest hypothesis forces us to examine the same action from another perspective. Imagine that you are trying to survive in an unknown forest. You do not know who is watching. You do not know how powerful they are. You do not know whether they are peaceful. Would you leave a sign pointing directly toward your shelter? Would you carve your exact location into a tree? Would you light a signal fire and wait for strangers to arrive? Perhaps you would, if you believed the forest was friendly. But if you believed the forest contained unknown and potentially dangerous beings, the decision becomes much harder. This is the central argument behind the modern debate over MET, messaging extraterrestrial intelligence. MET goes beyond simply listening. Instead of waiting for extraterrestrial civilizations to contact us, proponents of MET consider deliberately transmitting messages towards selected stars. The idea has supporters. One argument is that the probability of encountering a hostile civilization may be extraordinarily small. The galaxy is enormous. Civilizations could be separated by thousands of light years. Even if intelligent life exists elsewhere, the chance that a message leads to a direct confrontation might be tiny. Another argument is philosophical. If humanity wants to understand its place in the universe, someone has to take the first step. Perhaps silence is not safety. Perhaps silence is simply loneliness. But critics point toward a different problem. We have almost no information about the civilization that might receive the message. We do not know its technological capabilities. We do not know its motivations. We do not know how it would interpret our communication. And we certainly do not know whether it would consider humanity important at all. This is not really an argument about alien invasions. There is no evidence that extraterrestrial civilizations are preparing to attack Earth. The deeper issue is uncertainty and risk. How do you make an irreversible decision when you do not know the probability of the worst possible outcome? That is a question humans already face on Earth. But interstellar communication makes the uncertainty vastly greater. Suppose we send a powerful signal toward a star 100 light-years away. Someone receives it a century later. Perhaps they respond immediately. Their response reaches Earth another century after that. 200 years have passed. The people who sent the original message are long gone. The civilization receiving it may have changed dramatically. And the civilization receiving the response may be interacting with a completely different humanity. Interstellar communication is not merely slow. It is generational. A message becomes part of history before its conversation is complete. That makes intention difficult to interpret. And yet humanity continues to search. Because the alternative is to remain completely ignorant. Modern SETI research is also expanding beyond the traditional search for radio signals. Scientists are investigating laser technosignatures. They study unusual electromagnetic emissions. They examine planetary atmospheres for industrial chemicals that might be difficult to produce naturally. They consider large-scale energy use and other possible technological effects. NASA has highlighted radio and laser signals, artificial atmospheric compounds, unusual infrared signatures, and other possible technosignatures as areas of scientific interest. The search is becoming more sophisticated. But so are the reasons a signal might escape detection. A civilization could transmit only occasionally. Its signals could be tightly focused. Its technology could operate at frequencies we rarely monitor. Its emissions could be distorted by the environment between the stars. Even the plasma surrounding stars can alter radio signals as they travel through space. A signal might exist and still arrive looking nothing like what we expected. This is another reason the Great Silence must be interpreted carefully. Not finding something is not the same as proving it does not exist. Our instruments have limitations. Our searches have boundaries, and our imagination has limits. We tend to search for civilizations that behave like us because we only know one technological civilization. Humanity. Perhaps that is the greatest source of uncertainty in the entire search. We are looking outward, using assumptions created by beings who evolved on one small planet around one ordinary star. We do not know what intelligence looks like after 10,000 years. We do not know what technology looks like after 1,000,000. We do not know whether an ancient civilization would still use radio. We do not know whether it would communicate at all. And we do not know whether a civilization capable of interstellar survival would even consider biological life to be its primary form. The possibilities are enormous, but one fact remains unavoidable. Earth is no longer invisible in the same way it once was. Our radio emissions have been expanding outward. Our radar has reached beyond the atmosphere. Our spacecraft are carrying physical traces of humanity into deep space. And our deliberate messages have placed our species' fingerprints on objects traveling beyond the solar system. The sphere of our technological history continues expanding at the speed of light. With every passing year, the boundary moves farther outward. More of the galaxy becomes capable, in principle, of knowing that something technological exists here. A civilization thousands of light years away would not be receiving our first television broadcast today. It would be receiving the emissions that left Earth thousands of years ago. And a civilization 100 light years away could, in principle, be seeing a technological Earth, roughly a century in the past. The cosmic archive is already expanding. Our past is traveling outward. Our present will follow. And our future will leave its own traces. Imagine Earth from a distance. The planet is almost invisible against the darkness. No giant beacon, no cosmic advertisement, just a tiny blue world orbiting an ordinary star. But around that world, an expanding sphere of electromagnetic history moves silently through space. Inside it are fragments of our civilization, voices, music, radar pulses, television signals, scientific data. The first crude evidence that something on this small planet has begun looking toward the stars. For better or worse, Earth has already begun to introduce itself. And now the question is no longer whether humanity has entered the cosmic conversation. We have. The question is whether anyone is listening. And, if someone is, what they think when they hear us. What does the silence tell us about ourselves? After everything we have considered, there is still no confirmed answer. Perhaps we are alone. Perhaps intelligent life has emerged only once in the observable universe. Perhaps Earth is not merely one inhabited planet among many, but an extraordinary exception. A place where chemistry, evolution, intelligence, and technology happen to align across billions of years. That possibility is difficult to imagine. But it cannot be ruled out. There is another explanation. Perhaps they are there, but we simply cannot detect them. The universe is enormous. Light itself requires years to travel between nearby stars, and thousands of years to cross much of the Milky Way. A civilization may exist thousands of light years away, transmitting signals that have not yet reached us. Or perhaps its civilization existed thousands of years ago, sent signals. Long before, humanity developed radio astronomy and disappeared before we ever had the ability to listen. Our search is also limited by what we know how to recognize. We search radio frequencies. We search for laser pulses. We examine planetary atmospheres. We look for unusual energy patterns and possible technological signatures. But these methods reflect our own understanding of technology. An advanced civilization might communicate in a way we have never imagined. It might produce almost no detectable waste energy. It might use extremely narrow beams. It might communicate only rarely. Or it might have become so technologically different that our instruments would interpret its activity as a natural phenomenon. So the absence of a signal does not necessarily mean the absence of a civilization. And then there is the third possibility. Perhaps they are there, and they are silent by choice. Maybe advanced civilizations understand the risks of announcing themselves. Maybe they have learned that interstellar communication is dangerous. Maybe they follow a principle of non-interference. Or perhaps, in the darkest version of the dark forest hypothesis, they remain silent because revealing their location could make them vulnerable. But there is no evidence that this is happening. We have never detected a civilization hiding from us. We have never observed an extraterrestrial society deliberately suppressing its signals. The dark forest is a thought experiment. It takes the problems of uncertainty, distance, and survival and asks what strategy might emerge under extreme conditions. It is intellectually fascinating, but it remains speculation. The same is true of the Great Filter. Perhaps civilizations regularly encounter a barrier that prevents them from becoming interstellar. Perhaps the difficult step occurred long before intelligence. Maybe the emergence of complex life is extraordinarily rare. Maybe intelligence itself is unusual. Maybe technological civilization is fragile. Or perhaps there is no Great Filter at all. We simply do not know. And that uncertainty matters, because the location of a hypothetical filter would completely change the meaning of our existence. If the hardest barrier lies behind us, then humanity may be extraordinarily fortunate. Perhaps we have already crossed a step that almost no other world manages to cross. The silence would then represent rarity, not doom. But if the hardest barrier lies ahead, the silence would mean something very different. It would suggest that becoming technologically powerful may be much easier than becoming technologically enduring. A civilization could learn how to split atoms before learning how to manage conflict. It could build artificial intelligence before understanding its consequences. It could transform its planet before learning how to preserve it. It could become powerful enough to alter its future without becoming wise enough to control that power. Again, this is not a prediction. Humanity is not destined to fail. There is no scientific evidence that a great filter awaits us, but the possibility gives a different meaning to the responsibility of survival. If technological civilizations are rare, then preserving one becomes more than a political or economic objective. It becomes a question of cosmic significance. Imagine that somewhere in the Milky Way, billions of years ago, another species looked toward the stars just as we do now. Perhaps it asked the same questions. Are we alone? Is anyone listening? Should we explore? Should we speak? And perhaps that civilization disappeared before anyone could answer. We have no way of knowing. But if intelligent life is genuinely rare, then every surviving technological civilization represents something extraordinary. Not simply another species. Another opportunity for the universe to become aware of itself. That idea may sound philosophical, but it has a practical consequence. The longer humanity survives, the more opportunities we have to search, to observe, to learn, to send probes, to develop better telescopes, to examine distant atmospheres, to search for technosignatures, To understand whether life is common or rare, every generation can expand the experiment, and future instruments may transform the question entirely. Imagine one day detecting a repeating signal from another star, not a natural pulse, not interference, not an unexplained anomaly. A signal containing unmistakable evidence of technology. In that instant, one of the oldest questions in human history would change forever. We would no longer debate whether intelligence exists beyond Earth. We would know. The discovery would transform biology, astronomy, physics, philosophy, religion, politics, and our understanding of humanity's place in the universe. But there is another possibility. Perhaps we search for centuries and never find anything. No signal, no probe, no unmistakable technosignature, no evidence of another technological civilization. Even then, the silence would not provide a simple answer. It would still be possible that civilizations are too distant, too rare, too short-lived, too quiet, too different, or simply beyond our ability to detect. The universe does not owe us an explanation, and science cannot turn an absence of evidence into certainty. This is why the most honest conclusion is also the most unsettling. We do not know. The night sky may be a graveyard. It may be a forest. It may simply be empty. We do not know. But there is one thing we do know. For the first time in the history of our planet, one species has become capable of looking beyond its own world and asking whether intelligence exists elsewhere. We are the first species we know of to build radio telescopes powerful enough to listen to distant stars. The first to send machines beyond the planets of its own system. The first to place messages aboard spacecraft traveling into interstellar space. The first to recognize that the silence itself could be scientifically meaningful. We are standing at an extraordinary moment in cosmic history. Our civilization is still young. Our technology is still primitive compared with what may be possible over thousands or millions of years. And yet we have already begun asking questions that belong to the scale of galaxies. Perhaps that is what the silence ultimately reveals. Not that the universe is hostile. Not that aliens are waiting in the darkness. Not that humanity is doomed. But that we are still at the beginning. We do not know whether intelligence is common. We do not know whether civilizations survive. We do not know whether the galaxy is full of quiet worlds. We do not know whether anyone is listening. And we do not know whether our silence is temporary or permanent. Tonight, the stars remain exactly where they were before we began. Billions of distant suns, countless worlds, a universe almost impossibly vast. And somewhere among all of it, perhaps another civilization is looking into its own night sky, asking exactly the same question. Is anyone else out there? For now, there is no answer. Only darkness, only distance, only the faint possibility that somewhere beyond our instruments, beyond our assumptions, beyond the reach of our oldest radio signals, another intelligence is listening too. And perhaps the most important question is no longer whether we will find them. It is whether, by the time we do, we will have become the kind of civilization capable of surviving the answer.